All right, sorry about the yellow screen. We're going to continue the video reference, and we're on page 28B. So now we're going to look at what we never really talked too much about this, or ever really in the last chapter, but perpendicular lines and their slope. So here's an example of two perpendicular lines. So let's get the slope of each. So I'll start with this line called y1. You can tell one slope is negative and one is positive. So y1, let's get the slope here. So let's see. So from this coordinate to this coordinate, I'm going to go down and to the right. Okay, so it looks like I'm going down 8, right 8. So the slope here, so I'll write y1 m equals negative 8 over 8, which is really just negative 1. Okay, so now let's look at the other line. Now remember, to be perpendicular, I should have kind of said, we should write this in here. Perpendicular means that if the two lines do intersect, sorry, at a 90-degree angle. So unlike parallel lines that never intersect, this makes a 90-degree angle if they're completely perpendicular. That's 90 degrees. Okay, so now let me try this in orange. And again, my screen's all messed up here, but you can see that a little bit on your screen, hopefully. So now I'll call this y2. And this one's going to go up and over. It's very much similar. It's going to be up 8 over 8. So here I'll put m equals 8 over 8, which is now positive 1. So yeah, so I guess looking at that now, it could have been a little bit of better example I could have used, which I remember now from last year. But one thing you can, so let's kind of make a general rule. So again, this one was down 8 over 8. This is up 8 over 8. So if two non-vertical lines on the same plane have slopes that are, now we'll see this in another example, opposite reciprocals. So what that means, right, is they're opposite in the fact that one slope for them to be perpendicular has to be positive and the other one will have to be negative, so that way they intersect. And then reciprocal means the opposite of 8 over 8 is 8 over 8, which makes this a really bad example. So let me go back to Desmos like I did in the other video and give you an example of what I really should have showed you to begin with here. So go to my graphing calculator. So say I want to make two perpendicular lines. So I'll use 3/4 of the slope. So say I have y equals 3/4 x minus, x minus 2. Okay, so you can see that line's positive. So I know for my next slope to be perpendicular, I'm going to go y equals, this time it's going to be negative. Now instead of 3/4, what's the reciprocal of 3/4? You flip it and it's 4 over 3. 4 over 3, then I'm going to put it here, x, and I could do any y-intercept, maybe just like plus 2. So you can see now that if I zoom in a little bit, those two lines right there, that is completely perpendicular. Let's try another one here. Let's try y equals, let's try, what if you just had like negative 2x minus 5? Right, so I'll get rid of those. Could you think of an equation, wait, sorry, that didn't work, minus 5. Could you think of an equation that's perpendicular to that? Or tell me what the slope would have to be for that to be perpendicular. So what's the opposite reciprocal of a negative 2? Yeah, it would be y equals positive 1/2. So I'll put 1 over 2 x plus 1 maybe, right? So again, look at the reciprocals, the slopes. This is a negative 2. This is a positive 1 over 2, because negative 2 is really negative 2 over 1. Flip that 1 over 2 and make it positive. So going back to the notes here, you have some examples here. I'm going to have to make this into 2 videos because people are coming back from lunch very shortly. So it says determine which lines, if any, are parallel or perpendicular. So we need to get the slopes for all of these. So see how much I can do before I get cut off. So first thing, easy. This one's already in slope-intercept form, so that's m equals 5. The second one, I'll put it in slope-intercept form. So minus x, copy this down, 5y equals negative x plus 2. Divide everything by 5. So I'm left with y equals negative 1/5 x plus 2/5. All right, so now I'm left with a slope here of what? Negative 1/5. All right. Now if I just look at those 2 slopes, that looks pretty perpendicular to me, right? 5 over 1, what's the opposite reciprocal? Negative 1 over 5. So I'll say A, B are perpendicular. Just put perp for short. So let's see what C gives me for a slope. I bet you that'll be a parallel to something. So I'm going to solve for y plus 2x plus 2x. Negative 10y equals 2x. Divide everything by negative 10. Left with y equals negative 5 x. Wait, I did something wrong. I see it right here. Yeah, that's not negative 5. So 2 over 10 is 1/5. My bad. That's what happens when you rush. 2 over 10 is 1/5. So it's actually y equals negative 1 over 5 x. So now it lines up nicely that that one must be parallel to B. So I would say here that B and C are parallel like that. Okay. So in this last example, I might get cut off by people coming back from lunch. It says write an equation of a line that passes through this that's perpendicular to that. So I can use point slope for this. So this will be my x, this will be my y, and my slope here is 2. So the opposite reciprocal of 2. We just did that in the Desmos. So 2 over 1, the reciprocal is 1 over 2. And you make that negative. So pause the video, write that in point slope, and then change it to slope-intercept form. If you did it right, you would have got y minus, or I should say plus 5. Hold on, just wait out there for 1 second. Sorry, people get equals negative 1/2 x minus 4. And if you change it to slope-intercept form, you get y plus 5 equals negative 1/2. I could have just wrote a much, oh yeah, it has to go through that point. And then plus 2 when you distribute. So minus 5 minus 5, y equals negative 1/2 x minus 3. So just really quick, I'm holding people outside from lunch. I'm just going to go to Desmos just to prove it to you. If I graph those 2 equations here, let me get rid of these. You gotta take a quiz too, and I'm holding them outside. Sorry about that, guys. So if I plug them in, so I have y equals 2x plus 3, and then I have y equals negative 1/2 x minus 3. Ta-da! They're both perpendicular, and they're supposed to go through 4, negative 5. And they go through, where's 4, negative 5? Well, the first one goes through 4, negative 5. So that would be 4, negative 5 right there. Ta-da! All right, gotta go. Have a nice day, and we'll do the rest of the video reference for the guided notes in your next ed puzzle.